Good morning. Um, Today, we just keep going. I gave you what's homework number 3. To find the F test statistic, the ratio, and the p-value. So we are going to discuss how can we take um, the p-value and the F ratio. It's actually in the lecture note. One day, I gave you just a second. I didn't bring my lecture note. Just a second. I will be back. Okay, I'm back. Okay. Let me share the screen. Share the screen. Open the lecture note. Yes. It is the lecture note I gave you one day. And today, I want to do this example. In this example, it has the 5 regions: the Northeast, Midwest, South, and West. So first, most of you have a TI-84, and last time I introduced you how can you take the p-value, how can you take the probability. Can you see the screen? The table 16.3 and the Excel? Is anybody tell me? I think you can see the windows. So please let me know if you have any problem. Today, I want to introduce you how can we get the p-value and how can we get the mean squares in Excel, because it's all the people in UAFS. We can download and install the Micro Office 365, right? So if you didn't install Micro Office yet, then please go to the school website, and I'm looking for the link where can you install the software. So it's absolutely you can use the Excel. What is the name of the? It's kind of the spreadsheet in the Google. Numbers, sheets. Yeah, sheet. Yeah, I'm not sure if it has the function to get the probability for ANOVA, but absolutely today I wanna share how can we use the Excel. Okay, so let me plug the values: 13, 8, 11, 12, 11. And Midwest is a 15, 10, 16, 11, 13, 10. South 5, 11, 9, and 5. And West has 8, 10, 6, 5, and 7. Okay, so let me make bigger the Excel windows. And let me put a solid line at the bottom. Okay, here. Let me take the average because can I write here? Nope. Okay. We need the MSTR, MSE. It's both of them. We need the means, right? So at the bottom, go to the function, take the average from here to here, right? You know, the last column, the last cell is a blank, so automatically, even though I selected from A2 to A7, but the Excel can ignore the last cell because the last one is a blank. That is 11, and copy to right. So that is the averages, is XI bars. And also here, at the end, I need the overall mean, is X bar. So go to the function again, take the average again, and take the all of them. Yeah, that is a 9.8. It's a 9.8 is the overall mean. And let me take the NIs. You know, in Excel, we have a function of the count. As the name is the count, and just count is how many values. Here's a 5, probably copy to right. There's a 6, and the next one will be 4 and 5, right? So that is the NIs. So let me put one more column here. Here's the means, and here's the ends. I think the capital, it is not the capital N. Let me make the small n. Can I? Yeah, it's a small n's. And now even we can take the capital N, the overall sample size. So simply I just take the sum of the NIs. So it's totally, as we have a 20, the 20 observations. Okay? Okay, what I need. I want to take the MSTR, right? First, let me take the MSTR. For the MSTR, oh, I'm sorry, we need the SSTR first, and then simply divide by the degree of freedom. That will be the MSTR. Let me remind the formula. That was the sigma. Let me put here is the SSTR was summation Ni xi bar minus x bar square. It's good. So we need the difference, right? So it's equal x1 bar minus 9.8. Okay. So let me copy to right for 4 regions, right? And then let me take the square. You can put them together, right? Take the difference, square, and put them together, but I want to do step by step. So next one, take the square. I mean this one, right? And next time the sample size. So the next one will be the squared difference times the sample size, NIs. Then what? Take the sum. Take the sum of the all terms. How many terms? K of 4. Yeah, we have to take the sum of the 4 terms. Good? Does it make sense? So SSTR, it will be 105, 105.9. What did I do? Take the difference. XI bar minus 9.8. 9.8 was the overall mean. And then take the square. And then time the sample size, the B9 is over there, right? And then take the sum, okay? So exactly using the formula, yeah, we can take the SSTR, and now we just divided by is equal. Take the SSTR and divide it by, just a second. The degree of freedom, MSTR, that was the K minus 1. K, 4 minus 1 is a 3. So MSTR will be 35.3. It's good, right? And now, let me take the SSE. SSE, that was double summation xij minus xi bar squared. But we have another one. Can you remember that? It's another one. Ni minus 1 times si squared. You know the xi squared? It was the variance. You know, now we are using the Excel. Absolutely, Excel has the variance function. So today in Excel, I want to use the second equation. So first, let me take the variance. Let me take the variance here. Yeah, go to the function. Now it is not a common one, so you have to go to the select a category, statistical, and I need the variance, the V. So let me go down, V. And here's a function of the standard deviation. Yeah, here is the two functions. It's actually the four functions, but is the pair is the same functions. So the standard deviation dot P and standard deviation is dot S. You know the dot S is a stand for the sample, the standard deviation. But now we need the variance. Absolutely, we can take the standard deviation, then simply take the square. That will be the variance. But let me go down more. Let me go down more. Probably we have yes. We have VAR dot S. It is the what? Sample variance. Is it dot S? Is it standard for the sample? So let me take the VAR dot S and observations 3.5. The 3.5 will be S1 square. Okay. Then now let me copy to right. Then we can take all xi squares. So now what? I have to take the n minus 1. So n minus 1 times the variance. Okay? Yeah. It's before the take the summation. We take the multiplication. N minus 1 times the variance. And copy to right. And now we can take the sum again. It's a sum of the 4 multiplications. So now SSE will be 89.3. Then now let me take the MSE. Take the SSE over, let me see. The degree of freedom, you know, the MSTR is a degree of freedom, is a K minus 1. Can you remember the degree of freedom SSE, MSE? big N minus K. So the big N 20 minus K 4. So MSE is a 5.58. Then now we need the F ratio, which was MSTR over MSE. I'm sorry, it's MSE. MSE. So F ratio, the test statistic, it is a 6.32. Now p-value. Yeah, we have a function. So let me go to the function. It is not a common one either. So I have to go to the statistical category. And we need the probability from F. So let me go down and look for F. See? Here is some functions for F distribution. The first one is F dot dist. F dot dist is some, yeah, but anyway, take the F dot dist. It returned, let me see, it returned the left tail probability. It's good, right? But where was the p-value? Right tail, right? Now we have a F distribution. It's a non-symmetrical. Looks this, but we need the right tail. But unfortunately, the Excel gives us the left one. I mean, the left one is here, this one. What should I do? 1 minus, right? Because the overall probability from 0 to positive infinity always is any kind of the random variable is a 100%, right? So even though the Excel gives us the left tail probability, but simply just take the subtraction from 1, that would be the right one. So anyway, let me take the function, it's f dot dist. And the x value is the test statistic, the F score. And we need the 2 degree of freedoms. It's the degree of freedom 1 is a k minus 1, which was 4 minus 1, 3. And the second one is the 20 minus 4, 16. And now, yes, we need the cumulative. Yeah, we need the cumulative left tail probability, right? So let me type the true. I think you have to type the capital letter. Yeah, I think, but yeah, it's true. See, it is a 0.995. Where? Left tail. Then let me go up here. Yeah, I have to do 1 minus. Can you see the small letters up there? I plug the 1 minus the function to get the right tail probability because the right tail is a p-value. So now the p-value is a 0.0049. It's about the 0.005. It's very small. So if I suggest to you alpha 5%, it's absolutely the 0.005 is less than alpha. What will be the decision? Reject the null hypothesis. So yeah, you have it's a good calculator, but why not? Because using Excel is the Excel is another good calculator. Yeah. So it's not only use the calculator, but you can take the probability from the Excel. So do you have any question? Okay, then let me open the white page in Paint. Yeah, just let me make bigger. Let me make it the bigger size. No. Okay. Let me copy. Let me copy the scores. Yes. Look at this. Yeah, this one. So now we reject the null hypothesis because the p-value is very small. Even though I give you the alpha is only 1%, even we can reject the null hypothesis. So where it is? Yes, here. Yep. The null hypothesis, that is a mu1 is equal to mu2 is equal to mu3 and mu4. Today, I want to give you the alternative hypothesis, right? So please look at this. Not all the means are equal. Always the alternative hypothesis is this. So let me introduce you. Okay, let me say the null hypothesis, step number 1. The null hypothesis is the mu1 is equal to mu2 is equal to mu3 is equal to mu4. Because we had 4 groups, 4 regions, right? Now, we need the alternative hypothesis. Always, is any kind of null hypothesis, we just state alternative 1, it is an alternative 1. Simply, I can state not HA, sorry, not HO. Always. Because it is the alternative one, it's the other one, it's not HO. So now HO is this, right? So how do you think? What is the not HO? Not HO. How about this one? Is it not HO? Yes. Absolutely. They are not same. Is it good? How about this one? Yes. They are different. There are differences between HO and the statement. And also this one. I can make any, it's many things. It's many statements. Just not HO. Just not the null hypothesis. There are so many statements. How many? Let me see. Always, even though, we don't have a greater than less than. Before we said it is the great right tail. It was the right tailed, and the less than is a left tail. And together we said there's one tailed. Always in ANOVA, we apply the two tailed. That means it's not equal to. It's always we are using the not equal to, right? So in inequalities, inequalities is yes, no, right? It's 3 places. So the combinations is all combinations is 2 to the 3. So we have 8 combinations. It's one of them is a null hypothesis. And the other 7 kinds of alternative hypotheses. Yeah, here's I can state 7 more because it's 1, 2, 3, 4, 5, 6, 7 kinds of. It's a combination. It's not equal, right? In alternative hypotheses, all of them is the alternative hypothesis. It's a not HO, right? So we combine the 9 statements together. what will be? So now we have to state, see, not all means are equal. The other way, at least two. What does it mean? At least two. Two or more. Sometimes more. All of them is totally different each other, right? But in this case, it's the first group and second group is the same, but the others is different. And this case is 1 and 2 same, 3, 4 same, but it's between 1, 2, and 3, 4 is different, right? So either way, we can state the alternative hypothesis, right? So please remember the two statements. Is not all the means are equal, or at least two of them differ. So always we can state the alternative hypothesis like that, but the null hypothesis, that is the just equal. It's all of them. So let me summarize. Step number one, again, the step number one, the null hypothesis in general, as a mu1 is equal to mu2 is equal to up to mu k. And alternative hypothesis is not all means are equal, or at least two of them differ. So you can state alternative hypothesis the either way. And now the second step was the test statistic, which is the F ratio, which was MSTR, MSE, and the MSTR was the SSTR is over the degree of freedom, which was the K minus 1, and SSE divided by the big N minus K. And we can take the p-value from F distribution with the df1 is the K minus 1 and df2 is the big N minus K. And step 4, make the decision, reject the null hypothesis or fail to reject the null hypothesis, and finally we can make the conclusion. You know, the interpretation, the conclusion is the interpretation. Okay, so I can summarize the ANOVA by the 5 steps again. And why it is the analysis of the variance? Because we're using the two variances. The mean squares is actually, it is the type of the variances. So even though we compare the means, but we use the variance of the sample means. Okay, yeah. So it is a part of the numerator, part of the test statistic. So because of that, it named the analysis of the variance. Okay, so when you look at the note, yeah, here's a summary. Here's a summary for mean squares and F statistic in 1A ANOVA. And yes, this one. And now it is the picture, the visualization. We had the 4 populations, and we take the sample from each and compute the XI bars and compare them. Take the test statistic, p-value, decision, and conclusion. And we tried to make the decision in this example. Good, right? And it is the F distribution is a right skewed non-symmetrical. It's only positive parts. It's not non-negative because it is a ratio of the variances. Always the variance must be positive, right? It is the F-test statistic with the 2-degree of freedoms. Yes. The next topic is the identity, but today I wanna introduce you another sum of a square. Okay. Yeah. So let me clear up. Okay. So far, I gave you two sum of squares. The first one was SSTR. Yep, here it is, right? Yep. So let me take the double summation. Yeah, we have two forms, but let me take the double summation. It's a xi bar minus x bar square. Yeah, we have the other way. Yeah, that one. And the second one is SSE. Is another double summation, individual minus each sample mean, and absolutely, yeah, we have the other formula is here, right? But today, I want to use the first one. I want to use the double summation. When I add SSTR plus SSE, let me see. Here is the xi bar, and there is the xi bar. And here is the negative. So what I want to do now, in the right hand side, I just take the double summation xi bar minus x bar square and add another double summation xij minus xi bar square. That is what I want to do. I just add the two terms in the left, and we just add the other two double summations in the right. Good, right? Can I cancel out? Here is the addition, here is the subtraction, and here is the xi bar, and there is the xi bar. So I just cancel out, then say it's a double summation. It's the same as a double summation is xij minus x bar square. It means when I take the summation, yeah, double summation is a single summation, is the same summations, right? When I take the a minus b square plus summation b minus c, let me change. Let me change. It's the same order, right? Yeah, it's a c. When I take the c minus a square, it will be same as, it's a cancel out. It's a summation of the c minus b square. How do you think? You can check this one. I can say no. It is not true. Absolutely. You can try. You can expand the right hand side. We never ever get A. Right? And even though you can expand this one, you can expand that one. From here, we are going to take as negative 2AB, and here is a negative 2AC in the middle of the terms. Never ever cancel out, right? So no, it is not true. But in statistics, sorry, yes. It is yes. It's magic. Trust me. Yes. You can try. It is not easy. I don't want to take care of it, right? Any students in STAT department who major in statistics, yeah, it's many times we had homeworks to prove, right, why it is true. But statistics is not your major; it's only minor. So I don't want to ask you. But if you want, you can try. Yes, it is true. But not just this way. It's not just that way, right? You can expand the first summation, the first double summation square, and you can expand the second double summation squares, right? And fortunately, we can cancel out a lot. Then summarize again, we are going to take this double summation, finally, okay? So now, today, I want to give you the name of this one. It is TSS. What do you think the T stands for? What does T stand for? This one is a sum of square treatment. It's actually the between. It is the sum of square for errors, right? And here's the SS. Absolutely, that is stand for the sum of square. But at the beginning, it's a T here. Or sometimes it's SST, right? It doesn't matter. TSS, SST, doesn't matter. But what does it stand for? T. Please look at the summation, right? The reason why it was the between is we take the individual sample means from each and divided by the overall sample mean. That means when we take the sample means here, I mean the xi bars, and we take the overall mean, and we take the variance between groups. So because of that, it was the name, the SSTR. It's actually the treatment is from the between treatment. It's a between groups. And why it was the name of the SSE inside? Because the XIJ, the individuals. So now this way, right, in a sample, the individuals, right? And we took the XI bar, the sample mean in the sample, and we take the distance inside to individuals and take the variance, right? So SSE was the inside, the within variance. So because of that, it has the name of the within sum of square is the SSE. Okay, now look at this. Individual. Now I can make the data structure. Each sample is like this way. So individuals at the beginning, Xij, take out what? The overall mean. It's the overall mean, right? What does it mean? We can take the distance from the overall mean up to individuals, each individuals. What do you expect? What does T stand for? Total. The total sum of square. Okay? So it is very funny. Basically, mathematically, it is not true, but you can try. It is true, right? So finally, we have another double summation, individual minus the overall mean, square, then double summation. That will be the TSS. Okay? Let me try. Let me go back to the Excel here, right? We take the SSTR 105.9 is before, and here is the SSE 89.3. What does it mean? When I take another SST, how? From individual minus the overall mean square, then take the double summation. That will be same as the sum of the two sum of. Let me try. 9.8. 9.8 was the overall mean. Do you remember that? Right? So let me take the difference. Let me take the x11, 13, minus 9.8. Let me take x12, that is 8, right? Minus 9.8. Can you understand what I'm doing? Right? I don't have a space, so let me take the squares together. So let me go up to the difference, B2, 13 minus 9.8, open the parentheses and close it, and take the square. See that, right? Take the difference, x1 and 1 minus 9.5, 9.8, then square, right? So let me copy to right, or for the first observations in each sample, and let me copy down the most sample size is a 6. So yes, it's a 6 here, but let me delete this one because here was the blank, and let me delete them and delete one. Yes. So can you understand what I'm doing? Right? Yeah. So let me take the inside summation. What does it mean? It's a column-wise the summation in each group. So let me take the summation column-wise and copy to right. And then sum of the 4 sums, right? It's a sum of the sums here. Absolutely, simply I just take the sum of all. That would be same. That would be same. Right? Who is this? TSS. So using the formula, using another double summation, we take the TSS 195.2. But what did I say? It will be same as SSTR plus SSE. Let me take the SSTR plus SSE. Same. It's very interesting. It is the same. Okay. So today, I can give you one more sum of squares named the TSS, but it is same as the summation of the two sum of squares. Okay. It's before we take the individual, each sample variance, right? Let me take the overall variance. So let me take the function again. The VAR S, the VAR dot S again. And now it's not from each sample, but it's overall. So let me take them all. Let me take them all and take the variance. Okay? That is a 10.27368 is the overall variance, right? Let me take the TSS over 16. Why do I divide it by 16? Who was the 16? Sorry, no, not 16. 19. Look at this. Let me erase it. I want to show you later. Please look at the overall variance. How many degrees of freedom? The variance. And what is the formula for the variance? Overall. Let me go back to the blank screen. Okay, now here we have a data. It's xij's. I want to take the variance. It's overall. The variance. How can I take the overall variance? You know, it's actually the formula for the variance was the summation of xi minus x bar square over n minus 1, right? But now we have a 2 index. So the overall mean will be individuals here, xij's, and here's the x bar. Yeah, we had x bar. Who was the x bar? The overall mean, right? And take the square, and we have to take the double summation. Is 1 for I, 1 for j. Then what? We should divide it by the degree of freedom. Before, the degree of freedom is the sample size. How many samples is minus 1? Now, in a data set, is overall. How many observations? Big N, minus 1. Please look at the numerator. Who is this? It is the TSS over 20 minus 1. So let me we took the TSS and let me divide it by 19. That is what I want to do. So let me go back to the Excel. Yeah, it's already, we took the TSS over 19. Please compare these two. They are exactly the same. So what does that mean? TSS is absolutely, it is a part of the overall variance, the numerator. So we don't have to take the TMS, you know, always the MS from the SS, right? So always we take the MS from SS over the degree of freedom, right? So MSTR, that is the SSTR over K minus 1, and MSE from SSE over the degree of freedom. Now, when I take the ratio TSS over N minus 1, I can name it TMS. They are all the variances. It's a type of the variances. See, sum of square over the degree of freedom. The sum of square over the degree of freedom. So we can define it's another variance. is the name, the TMS or MST, whatever, right? Yeah. What did I say? When I add up, it's a sum. That will be TSS, right? I said that SSTR plus SSE is equal to TSS. It is a fact. Can you add the degree of freedoms? N minus K plus K minus 1. How many? We can cancel out. It will be big N minus 1. Oops. It will be big N minus 1. Not only the sum of squares, but also the degree of freedoms sum up, that will be same. Okay. So now let me go back to the lecture note. Yeah. We can make the ANOVA table. I want to copy this ANOVA table. Can I make a little bit smaller? Yes. And it's a copy here. Yeah. It's ANOVA table. So we can, yeah, it is a treatment. So here is the SSTR and MSTR. It's a summarized, it's a summary table, right? And here is the SSE and MSE. And here is the TSS. And in the first column, there's the degree of freedom, which was K minus 1, big N minus K, and the last one will be big N minus 1. We don't need this one. Okay, so let me copy. Let me make the Excel file is getting smaller. And let me make this one is the other way. And I want to copy. K minus 1 was a 3. It's a 20 minus 17. And just a second, no. 12 minus, oh, I'm sorry, the 16. It is a 16, right? Because the 20 minus 4, and this one is a 20 minus 1 is 19. And that is the 4 minus 1, right? And SSTR is a 105.9, and SSE is 89.3. And the summation, or the other way, the double summation, the TSS was 195.2. And also, we take the MSTR. MSTR is a 35.3, and MSE is a 5.58. And the next column is a F statistics, the ratio, which was the 6.325, and the p-value is a 0.005. So we can summarize the statistics. And here's a blank, 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 and blank. It's good, right? So we can make the ANOVA table. Okay. I want to stop the lecture here, but already I made the homework. Okay, let me go to the homework. Okay, let me go to the assignment. Yep, here's a homework number 5. It's due September 15. That is, I think, the next Tuesday. Yes, next Tuesday. And as a question number 1, I think it is a simple one. Find the degree of freedoms. The numerator and the denominator is actually the first one and the second one, right? The simply you can answer is the first one is a 10, and the second one is a 4. Yeah, but I just want to ask you, we need the 2 degree of freedoms. It's the top one and the bottom one, right? It's the first one and the second one. And C is to take the SST all, MST all, is SSE, MSE, and F ratio. Yeah, it's a try again, it's with the samples. But look at this. When you click the blue icon here on the right top of the table, the data, then you can open them in Excel. Just a second. I think I should have a pop-up window somewhere, but I think because of the corroborate, I can see. Yeah, here it is. Yeah. And now open them in Excel. Yes, here. And now you can take the average sample size and take the SSTR, SSE in Excel, right? Yeah. So in this homework, I suggest to you, yeah, I recommend you open them in Excel, and why not? Yeah, absolutely. If you want, you can use a small calculator, but I think the Excel is better. So you can do more practice using Excel and take the SSTR and SSE and MSTR, MSE, right? Yep. So you can do that. And it's a similar one, yeah. It's how many degree of freedom, yeah. So one by one. And finally, it's later one. I ask you the bigger problem. It is it's notations, right? But yeah, I gave you the bigger one by the 5 steps. It's a state null hypothesis, alternative hypothesis, and the test F ratio, the test statistic, and probably the next part will ask you what is the p-value. Then you can take the p-value, you can take the probability from your calculator or even from Excel and make the decision and the conclusion, right? So please do the homework number 5 is until it's the next Tuesday in this weekends, right? And we are going to discuss the homework number 5 on next Tuesday. Any question? How can I go back? Okay, I want to stop the collaborate right now and have a nice weekend and see you again on next Tuesday.